upload. Anyway, so yesterday in 7.1 we were doing the area under a curve. You can go ahead and send that up. And we are today going to be working with making horizontal slices, because you don't only have to color vertically, you can color horizontally if you would like. 9 times out of 10 it's worse, 9 times out of 10 it's more difficult, but 1 out of 10 times it's the only way to do it, and so we need to know how. So I'm going to demonstrate in your notes. I know example 5 we have not done yet. I don't think we need to. I want to go right here and demonstrate with a very easy function. So let's go take and graph the function y equals the square root of x. We're going to do this the way we did it yesterday, and then we're going to discuss how we do it when we make horizontal rectangles. So we've got our nice easy parent function, shouts out from here, and it's being bound also by y equals 0 right here, aka the x-axis, and by x equals 4. Let's put that right here. You can go shade that in. And that's the region we're finding the area of, is the one encapsulated by all this blue stuff right here. So I'm going to go on the top of here, right, y equals the square root of x. And we're going to go ahead and begin. We're going to go do these vertical slices. So I'm going to draw one representative rectangle. Keep in mind they're infinitesimally thin, and there's an infinite amount of them. So every base of that rectangle is a tiny little change along the x-axis. So we go put our bases of our rectangles on there. We are going to color this way. So I'm like coloring like this, and they're just so thin in these rectangles. When I finish coloring, I will have the area of the whole rectangle, of the whole region. So let's go do that. We are going to be coloring that way. So from 0 on out to 4. And then we just need to get the height of every rectangle. We good? All right. So on the top of the function right here, to get the height of the rectangle, when I go on here, I'm going to erase that little top part right there. And I'm going to write that as a point, because it actually becomes important with the dy's. The dx's, it's kind of obvious, but this is the point x, and y is a function of x. And so when I'm doing how high this is, it's going from 0 up to root x, or root x minus 0. So we do top function minus bottom function, and the 0 is not necessary, and we're going to go math 9 that on our calculators really quickly. So let's go do that. Go grab a calculator if you do not have one. Hit your math 9 option. Enter your function with respect to x from 0 to 4. And if we're on the old operating systems, we do our fint, and it'll look like root x, x, 0, 4. New operating systems is a piece of cake. Hit enter, and we aren't going to integrate by hand today because we're going to be pressed for time to get everything in, even with our calculator doing a ton of the work. So we get about 5 1/3. If we had done it by hand, we would have had 16/3. All right, so now we're going to take the exact same problem, and what we're going to do is we're going to color a little differently here. So with horizontal rectangles, what you're going to do is quickly draw that same thing. All right, and go sketch it. I've kind of deja vu here. I just did this, but I'm doing the same problem. I'm just going to do it a different way. So go ahead and send your root function on out, and we're sending it out to x equals 4 again, and you should go shade that in either with a highlighter or a colored pencil. Go shade that in. This time though, instead of coloring up and down, we're going to do what we call horizontal slices, which actually means instead of heading along the x-axis and having x limits and a dx problem, we're going to head and color up the y-axis. And when we make a rectangle, go make one in there with whatever color you need to. And the rectangles become more and more important as we go through. Now our height of the rectangle, or that little base, is not dx, it's dy. It's a tiny little change along the y-axis right here. So we would have to integrate with respect to the y-axis, so everything has to go in terms of y. So my limits of integration are no longer from 0 out to 4, they're from 0 up to the y-coordinate here, which is the square root of 4. So my limits are changing because I'm coloring differently, right? I'm going to be coloring longer slabs, but I'm going to be going up a shorter height. The problem is the integrand also needs to be in terms of y. So I cannot go put any x's in my integrand. There's no variable mix match. So when I go on here, right here, this x is a constant. It's 4. I don't even care what the y is. I know it's out 4. This right here, though, you know how this was x comma root x? Go point at where it hits over here. That's got to be a function of y, which is awkward because we've never had functions of y before, where your calculator only takes y equals something x, right? But we want it to spit out the x in terms of y. Well, it's pretty easy because here's your function. It was y equaled the square root of x. I want to know what x is in terms of y. What would it be? X equals y squared. You can even see it with the numbers. Yes, y is the square root of x, but x is also y squared. Do you see the relationship? We're just used to putting an x and having the function poop out y. We want to have the independent variable become the y and get back to the x. So you just solve it. So on here, my x is actually y squared. So this is not considered x root x anymore. We're going to call it y squared y. It's the same thing, right? So now I need to color up like this. I've got the base of mine being dy, but instead of doing top minus bottom, guess what I do? What do I do? You can say it. It's weird, I know, but you go ahead and say it. You do right minus left, exactly. So we're going to go do that. We're going to take 4 on the right minus the left function. So I'm getting the length along the x-axis in terms of y. Now, if we go integrate that and math 9 it, you might say, well, my calculator doesn't have a y button. Your calculator can't think. It doesn't know that you're working with y, so you're just going to enter x's again. So you're just going to go math 9 it. Let's go do that. You should know how to do it by hand, but for time purposes, let's just go enter it. We are going to be doing the function 4 minus x squared. Your calculator couldn't care less what variable you enter. And we're going to go from 0 to 2. And it shouldn't be any different because we're coloring the same picture. We're just coloring it with a different motion. That is sweet stuff right there, right? That's pretty cool, right? All right. So on the next page, we are going to go and continue. We're going to do the horizontal slicing method, and then I'll have a discussion of how do you know which one to use. Most of the time vertical, but we're practicing horizontal today, and sometimes horizontal is best. We'll talk about that. Using horizontal slicing, so let's go through another one on here. Let's go like that. Almost looks like the same problem, but it's going to be greatly different. We've got the square root of x, again, shouting out. Let's go do that. And I'm going to go put that in a color so I know I'm being bound. You might want to take out a colored pencil or something or a highlighter. Also, y equals 0, so I'm actually got to stay in that little wedge right there. And then I've got a line also that I need to create my region. And it's the line y equals x minus 2. So when I go graph that, I'm down at -2. And I go up 1 over 1, up 1 over 1, up 1 over 1. I've got a line going like this. And I'm going to go label it. That's y equals x minus 2. And this blue function over here is the square root of x. It's nice and color-coded. I would now go shade my region that I'm finding the area of. So if you could, go shade. I'll outline it in green. I don't like to shade on here, but we're going to go shade in this thing. All right. Now, if you were coloring vertically, which actually most people don't, by the way. It's natural for right-handers to color like this. Did you know that? If you're actually coloring, this is awkward for a right-handed person. But we are going to decide if we would like to color horizontally or vertically, but we're going to do it horizontal. Don't write this on your notes. If I were coloring vertically, watch what would happen. I would color, color, color. But when I get to here, my bottom function changes. So I'd have to separate my integrals into two pieces because top minus bottom up to this spot is the square root of x minus 0. But once I hit here, it becomes the square root of x minus the line. So I'd have to do 2. But it's perfectly legal, and I could do it, and it actually wouldn't be very difficult. But if I color horizontally, let's go do that. If you start coloring like this, there doesn't have to be any change in integral, because on the right is always the line, and on the left is always the root. So I can do it in one integral. So this one might be a horse apiece. I actually still would go vertical if it were me, because these are both solved for y in terms of x. So even though I'd have to split it up here at x equals 2, how do I know that's at x equals 2? Because it's the 0 of the function, right? But let's go put this dot on here so we kind of know how we're integrating. What point is that? Maybe you just know it. So let's stare at it for a while and figure out if we could avoid some algebra and not have to go to a calculator to decide what point that is. What point works in both of those? Maybe you could just guess. 4, 2. And if you can just see it, don't waste time doing algebra. If you couldn't see it, though, you'd have to set the functions equal, right? And solve for x, which always means get one side equal to 0, and factor. Right? All right, so let's go do that. We're going to color, but we're coloring this way, so be very careful when you're doing horizontal. Everything is in terms of the y-axis. You're coloring up the y-axis, so we're going to go integrate. All the way from 0, not out to 4, but up to 2. We have a dy problem. Here's the problem. dy requires no x's. Limits y, integrand y, differential of y. So you have to go back to your little representative rectangle, and it's kind of small right here, but you kind of got to picture these points. You got to picture their x values, but your independent variable is y. So you need to go back up to your functions. Let's go right here, and you need to get them as x equals. It's not that it's difficult, it's just weird. So for the line, instead of y equals x minus 2, like life has always told me, x goes in, y comes out, I'm going to change the game. I'm going to say no, x equals y plus 2. Same thing. All right, there it is. That's my right function. It is y plus 2. That's how far out I am on the x-axis. Then I would go to my other function on the left, because I want you to point at that. You are doing right minus left. All right, the leftmost function, in terms of x, it's x comma root x. Don't want that anymore. I want it to be a y dependent variable. So you go up here and you solve it for y. And you would say that means x equals y squared. And now we do right minus left. So we need to take out a calculator and go math 9 it. And I'll wait to get an answer here. So take out a calculator. We're going to math 9 it. Give you a little time to do that. It would be the line first. X plus 2 minus x squared, and with respect to x, from 0 up to 2. Answer 3 1/3, aka 10/3. Now, had I done coloring vertically, I'm going to show you the setup, but we're going to go really quickly. Had I colored vertically, just to kind of make sure you understand the difference. If I had colored vertically, watch what I would have done. Go over on the top, maybe split this and write vertical. It's getting kind of busy here, but that's okay. If I had done vertical, my limits would have gone along the x-axis. It would have been a dx problem. I would have had an issue at 2. right? So at 2, what I would have had to do is stop, because the top function is root x, the bottom is 0, but then from 2 to 4, the top function is root x, and the bottom one is the line. What was it, x minus 2? I'd have to do a little split there. All right, so one more of these, and then we're going to, this is calculator active, by the way, so write calc active. Not that you shouldn't be able to do part of it by hand. So let's go as we normally do. Let's go graph it. Too slow, too fast, or just right? Oh my God, you won't talk to me. Too slow, too fast, or just right? All right, thank you. So let's go. We're going to go graph it. The cubic function's parent function is super easy. So let's go take that and graph our parent function. No matter what, in order for you to graph them, you have to solve them for y anyway. That's one of the reasons vertical is usually your go-to method, because I can't graph x equals y squared, nor can my calculator. It has to be solved for y. So you might want to point at that and write solve for y for graphical reasons only, even if you're not going to use it. By the way, when you see this, I'm going to have, if you have a highlighter or a colored pencil, that right there, when they say x equals instead of y equals, that's kind of a red flag that you are going to be using horizontal, or at least it'll be in contention. Usually if they both say y equals, vertical's your go-to no matter what. But that x equals, that's kind of a, that should kind of trigger something in your brain. I may be coloring the other way. So let's go. In order to graph it, I'd have to say y squared is equal to x plus 2, because we only have been taught how to graph our functions when they're y equals. So then my y is not equal to the square root of x, it's plus or minus, and that's really important. So you might want to take your colored pencil and circle that plus or minus there. We have to go back and remember our square root function does this shout out. But this one will be from negative 2 is when it's 0. So it's going to shout out from right here. It's going to go like this. Let's send that way. And let's send this way. And then I take out a highlighter or a colored pencil and shade in the region under discussion. At this point, once it's graphed and you're kind of trying to decide what you're going to do, decide what would be best, to color vertically or to color horizontally. Here's how you make your decision. This is one of the more important things I tell you today. When you're trying to decide, because honestly, they can almost all be done both ways, but when you're trying to decide if you should go like this or like this, go start vertical first, because that's your easiest, because we're used to y equals. But when I go vertical here, you'll notice top function and bottom function are the positive and the negative root, which would be fine, because when I do root x plus 2 minus a negative, it'll add it, I'll get this length. It'll be fine. But once I hit here, I'm going to have to switch, because now my top function would be the curve and my bottom would be the line. So when you have to switch and split your integral up, try going the other way. If you color this way, boom, 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 always on the right is the cubic. So you can do it in one integral. And that's probably the most important thing I tell you, is when you're trying to make the decision, try to only have one integral if you can. It makes it easier. So I am going to color up the y-axis because right stays the same. If I go vertical, I've got to switch, which I could do, but I don't want to. So let's go set that sucker up. We are going to integrate up the y-axis. Well, in order to do that, I need to find my intersections. So you need to graph it and calc intersect. I need that side over there to go get me the y value right here, and this side of the room over here to get me the y value right here. And I only need the y value because I'm going up the y-axis. If I was coloring vertically, I'd ask you for the x value only. So calc intersect. What was this y value right here? I need it. And I need this one here. What's the one on the bottom? You got it? It should. -1. That sounds familiar. So we're going from -1, and then we're going to color up until we get to this y value. I'll take it to 3 decimal places, although we could store it in full, but I'll just take it to 3 decimal places. How high up do I have to go? What was that? 1.793. Okay, perfect. So now I've got my limits of integration. And I'm doing a dy problem, so I need to go back to my representative rectangle, and I'm going to color it in, and I need to figure out this with y going in. It's getting messy, but follow it. And over here with y going in. AKA, they both need to be solved for x in terms of y. This one already is, so no work. This one is not, but it's super easy. X would be the cubed root of y. So let's go put that on there if we solved that. X would be the cubed root of y. Now just be careful because you have to do right minus left. If you don't, you'll get a negative answer, and that should stop you because you can't have negative area. That doesn't make sense. You can have a negative integral, but you can't have a negative area. And we're forcing, because we're going right minus left, when you do positive minus a negative, it'll add it. So I need to do my cubed root of y minus my y squared minus 2 and do it in parentheses, and then I'd go math 9 it. And I'm confident we can all math 9, so we're just going to move on. All right, now we'll get something interesting. All right, next one up. We are going to do example 8. This one will be calculator active. So I'll give you a minute. Let's write calculator active on the top of that. Let's go clear out the last problem you did. So let's write calculator active. And let's go do it. So first of all, let's go graph. On my calculator, when I go graph each of these, what's going to happen is when you put them in a standard viewing window, it looks really small. So you're going to hit your y equals. You're going to graph e to the x plus 1. And then you're going to graph 2 minus x squared. So you're going to have that exponential and that upside down parabola. And yours isn't going to look like mine because I have zoomed in. So what you need to do is you're going to see like a tiny little, it's going to look almost like they're touching each other if you're in a 1x10 window. Go hit zoom and hit zoom in so you can at least see that there's a little football region. If ever you can't see the intersection, either mess with your window and blow it up or just zoom in. So when I zoom in on that, let's go make a nice big upside down parabola, and my exponential was heading like that. And then we can go color in that little football right there. That's what we are trying to find the area of. If it was your choice, based on the equations and based on the region, and if you're going, I don't know, should I do vertical or horizontal? Your go-to is vertical, and that's perfect here. Because the top function is always the parabola, and the bottom is always the exponential. So if it were your choice, you'd go vertical. Okay, next step, I need to find the intersections. On my calculator, I need to calc intersect, and I would like the left side to do this point, please, because I need both the x and the y, because I'm going to do it both ways, vertically and horizontally. And I need the right side of the room to calc intersect over here. And let's just put calc intersect. And we'll write those down right here. I need both coordinates, actually. Well, duh, this one's easy. That's 0, 2. So let's change that. I need only that left-hand one. And I would like to steal it. And it looks like it is negative 0.715. I would normally store that, but for today, I want to get done here in the time I've got. 1.489. So next, I've got my intersections. I did it on my calculator. We are now going to integrate vertical slices and horizontal slices, and then I'll stop the recording. So for my vertical slices, I'm having a hard time with the scrolling. Let's go do it. Vertical would be, if you had your choice, you wouldn't even choose horizontal because they're solved for y. If it said x equals, then you might want to do them. Right? Yeah, I am right. All right, let's go do it. So our vertical slices, I'm going to go draw one just right here. A little change along the x-axis. Bam. Integrating along the x-axis. So from x to x, let's go set that up. Negative 0.715 to 0. Top function minus bottom function will give me my height, which some books call a function in and of itself. They'll call it h of x. So my top function was the parabola. What was that? 2 minus x squared. So let's go enter that. 2 minus x squared minus the bottom function, watch your signs, e to the x plus 1, everything x. X limits dx, integrand x, off to the calculator, and I want an answer because we are going to compare it to coloring the other way. All right, so I will steal that answer. If you do it correctly, it takes a little longer on the TI-83 and the Inspire, so we will hold up and wait for you guys. I'm assuming this is right. Can you give me the thumbs up on a backer on that? I just stole it. Anybody else? Yes? All right, super. So there it is. Last, and then we'll go do the other ones separately because I like to keep the recording. Sometimes YouTube will wig out if I go over 25 minutes, so I'm hoping this will upload. All right, here we go. Horizontal slicing, same exact problem. Here we go. We're just going to color up. So let's go up there and pretend we're coloring this way. It's not that it needs to be split up. That's not why I wouldn't choose this. It's because I need to solve for x in terms of y, and that requires manipulation. So it would not be my go-to for this one, but we should know how. So let's go do it. I'm now going to integrate up the y-axis. So from 1.489 up to 2. It's a dy problem. Here's the problem. Those aren't y functions, they're x. So we need to take and go fart around with them. So let's go do that. The parabola was y equaled is 2 minus x squared, I think, right? Yes, 2 minus x squared. That one's easy to solve for x. I just add the x squared over. Get x squared is equal to 2 minus y. And that would give me, I'm going to go down here, I'm running out of space, x equals plus or minus the square root of 2 minus y. You just need to decide which one to use. And for that football over there, the x's are negative. See what I mean? So I'm going to use the negative. So if you even wanted to go put a little dot here for your length right there, that point, if I were to label it, would have been negative square root. And I forgot what it was. What was it? Square root 2 minus y. All right? So that's the first one. The other one is this function, y equals e to the x plus 1, needs to be solved for y. So a little flashback to some algebra 2 / pre-calc here. When I solve that for x, I need to subtract 1. So I'll get y minus 1 is equal to e to the x. I then have to remember how to undo e. What's the inverse function for e? Natural log. So I need to natural log both sides, and I'll have ln. Notice this is much more cumbersome than vertical, and it usually is. When it's not is when they're both given as x equals. Or when you start to color vertically and you're like, oh crap, I gotta separate my integrals because the tops and bottoms change. So I would have ln e y minus 1 equals ln e to the x. And ln undoes e, so that's just x. Now what I just have to be careful of is who's the right function and who is the left function. So back up to the football. I need to do right minus left. I need this one. And that was my e function. So I need to do ln y minus 1, right function, minus the left. So be careful, because I'm going to be doing minus a minus. So I'm going to write a plus. That'll be a plus root 2 minus y. Then you go to your calculator. Your calculator does not care what variable it is. If we have not made any silly mistakes, it doesn't matter how I'm coloring. It's the same amount of area. So if you crank that sucker out, you will get 0.082. All right, so I'm going to stop this.